Find expressions. I'm going to go, since we have a short day, to this bottom part, and then we'll go to Mrs. Thornberry. So we have expressions, terms, coefficients, and like terms. So what I want you to think about is all of these here at the top are expressions. So what an expression is a mathematical phrase that can contain numbers, letters, which letters we're going to call variables, and operations like addition and subtraction. And the most important thing is that an expression will not have an equal sign. Those are called something else. We have within that expression terms. A term is a constant or a variable in an expression, separated by addition and subtraction signs. Okay? So this is what I like to tell students. Everybody knows what a train looks like, yes? Yes, no, maybe. Yes? Okay, so an expression is this whole set of cards attached to each other by addition or subtraction. That's the expression. It's this whole thing. A term is just the little cart in the train, like that guy. That's the term. So the expression is the whole train all together, and the term happens to be that one cart if we were to look at it without looking at the rest of the train. Does that make sense? So usually trains are attached with chains or whatever. I don't know what they're attached with. Our terms are attached with addition and subtraction. So if you look at this example, this guy is on its own. That's one cart of a train. This guy has two carts. Does that make sense? So that means it has two terms. And then this train here is a little bit longer. How many carts does this have? 3. So it has 3 terms. Does that make sense? Yes, no, maybe? Yes. Okay, perfect. Coefficient. A coefficient is the number in front of a letter. So I'm going to start calling letters variables. The number in front of a variable. So if I have 4.3x, this is my coefficient. 4.3, okay? Like terms, they have to have the same base or variable and the same exponent or power. So they have to have the same letter being raised to the same exponent, the same power. So now that I gave you a little bit of background information, so if we look at this guy has how many terms? 2 terms, right? This guy only has 1 term, and this guy has 3 terms. They're all expressions though, right? The first one's a small expression, then you go kind of like mid-size, and then the last one is a longer expression. Can they get really long? Yes, they can. Okay, they can be very, very, very long. But just like the train, are all trains the same size? No. So they may vary. Okay? So Mrs. Thornberry wrote 3 examples of expressions on the board. Using examples, write your prediction of what makes something a mathematical expression. So with the vocabulary I gave you, what makes something an expression? Rory, yes. Addition, subtraction. What else? Yes, Zach. Numbers and letters. That's all that is. Numbers, letters, and addition or subtraction. Okay? So use these definitions to help you complete the following. Give an example of an expression with 4 terms. Remember, expression is the train. So I want to train an expression with 4 terms, with 4 cards. Who would like to give that a try? So we want to come up with something that has 4 carts. Come on, you got this. Yes.
Negative 5x plus 9y plus 6 or minus 6.1y
minus 6.1y. Sorry, yes.
And then plus 3.1x.
Plus 3.1x.
1.
Does that work?
Yeah.
Excellent. Yes, he has his 4 carts. 1, 2, 3, 4 carts. And they're attached by addition and subtraction. Perfect. Does anybody have a different example? Fernanda, what did you have?
Oh, I had 13x plus 9y plus 8 plus 38.
Okay, same thing. Does that work? Yes, you have 1, 2, 3, 4 cards connected by addition. Okay? All right, now list all of the terms in the expression below. So remember, which ones are our terms? The what of the train?
Single part.
The single cart. Good job. So which ones are our terms? 6x. We don't include the addition or subtraction. So 6x, what else? 10y. What else? 13. And
5z.
good job. 5z, because we don't include the addition or subtraction. Okay? Now, list the coefficients. Which ones are the coefficients again? In front of the letter. It has to come with a variable. It has to come with a variable. So, what's the number here attached with a variable? So, okay, now, it's just the number. So, do I say 14x or just 14?
14.
Okay, 14. What else? 7. What about 1? Why not? Good job. It doesn't have a variable. What else? 2. And yeah, we can debate whether it's negative or positive. I'll get to that, okay? So next, it says, give an example of a like term. Remember, for like terms, they have to have the same variable and then the same exponent. I'm just going to put EXP, exponent. So just like you would keep oranges with oranges, apples with apples, you're going to keep x's with x's, y's with y's, b's with b's. Does that make sense? So if I wanted a like term to 14y, what's another term that would be similar? Yes, go.
5y.
Good job. 5y. And don't be afraid to use negative numbers if your heart desires. B, negative 9b. What's something that sounds like negative 9b? Yes. 9b. Okay, perfect. Positive. As long as it has the same variable and the same exponent. What's something that's similar to 200? 300. Okay. 300, 3,000, 321, 399, negative 1, whatever. What is something that sounds like h squared? Remember, same exponent, same variable.
2h squared.
Good job. How about 2h squared? What if we make it negative for the fun of it? Yeah? Keep things spicing up in math class. All right, so we have the same variable and we have the same exponent, okay? Are we okay with our vocabulary? Yes? We're going to have to remember that vocabulary. Circle the letter of any card that gives an example of like terms. Do these two guys look like terms? Well, let's check. Do they have the same variable? Does the variable have the same exponent?
Yes.
Yes, because it's a little 1, remember, that it's hiding? So yeah, we're good with that one. What about B? Do we have the same variable? No. The second 2.2 doesn't have the end. Why do you think this might trick somebody?
Because it's the same number.
It's the same number. What's that number called on the first one? It's a coefficient here, right? But it's a constant over there. Okay? What about this? What's wrong with it?
It's not the same variable.
It's not the same variable. What about this? Why?
Same variable. And
The same variable and the same
exponent.
exponent. Good job. It might be tricky to some of us because this guy has a 5, a coefficient, and the other one doesn't. But that's not what we look for, right? What about this guy?
Wait, yes.
Actually, yes.
Yes.
Why?
Because they're both, they have the same.
They don't have a letter, right? They don't have a variable.
Yeah, I mean,
So they're both of these called constants. Yes. Constants are any numbers that don't have a variable, okay? You're going to want to remember this. Today is the easiest day of the lesson, and it's the part that students miss most on the test. Why? Because you don't study your vocab. So we're going to get to do math with it. But if you're good with your vocab, I promise you'll do well on your test. Okay? So I think we have a little bit of time to start the next one. I know today we have a short day. So back here, we're going to talk about like terms. So what does it mean to simplify? Like,
Make small.
okay, what else? Make smaller.
The nearest number.
Say that again.
To the nearest number.
Make it the simplest. Make it small. Yeah, keep things simple, right? So what simplifying expressions look like is getting a really long train into a more condensed version of that train. How am I going to do that? Let's pretend my train is carrying, I don't know, animals. What it's going to look like is putting all of my carts, all of the horses in one cart, all of the chickens in another cart, all of the cows in another cart. Does that make sense? So we can simplify algebraic expressions by combining any like terms. You have to be careful when you're combining like terms because you have to check the sign that's in front of them. So you have to check whether you're subtracting or adding. So, for example, you have a group of friends who went to the movies. They bought tickets. Now I want to go to the movies. They got tickets, drinks, popcorn. So you see the picture of the popcorn there, the tickets, and the drinks. Using these variables, write an expression to represent the individual items purchased. Basically, how many popcorns were there bought?
3.
So, and how many tickets?
3.
And drinks?
3.
So, for tickets, they gave us the letter T. So, 3 tickets plus 3 drinks plus 3 popcorn, 3P. Can I combine anything? No. Why not? Different variables. And are you going to combine tickets with popcorn?
No.
No. Okay.